whenever we have the summation of a finite geometric series, okay, like I said, it's going to be a lot bigger, okay, as far as your numbers are concerned, because you're multiplying instead of just adding everything up. So whenever we have the formula for the summation of a finite series, it's very similar to what we did with arithmetic in terms of it's going to be S sub n instead of A sub n. We still have to know what the first term is. We need to know how many terms, and we need to know the common ratio. You will have to divide, but again, just like it was before, unless you have any sort of a common ratio that is anything that's not a whole number, you're going to have a nice, neat number. It may be larger than normal, but it's still going to be a nice, neat number as far as no decimal, no fraction, things like that. Okay? As long as your ratio that you're multiplying continuously by is not a fraction or a decimal. So a sub 1 times 1 minus r to the n power divided by 1 minus r. Okay? So you're going to have normally a negative number, okay, on top and on bottom, and then whenever you divide there. So if we find the sum of summation from 1 to 10, where your rule is 4 times 3 to the I minus 1 power. Okay, so it fits the same rule as it did yesterday. Okay, in terms of you have your first term, you have your common ratio, and then I in whatever variable you're going to use to the n minus, or in this case, the I minus 1 power. Same way that we dealt with yesterday. Remember, we had a sub n from yesterday that was a sub n equal to a sub 1 times r to the n minus 1 power. Whereas for today, everything's going to fit s sub n equal to a sub 1 times 1 minus r sub n over 1 minus r. N, I, k, whatever variable you're going to use, still the same thing. Okay? The one in black was from yesterday, the one in orange is what we're using today. Okay? But we can use what we have from yesterday in terms of, especially if it already fits the rule from yesterday, we don't actually have to plug anything in, okay, to find the first term. In some cases, like on the second one, we're going to have to figure out what the first term is by plugging 1 in for I in whatever our variable is. But in this case, on the first one, where it's 4 times 3 to the I minus 1 power, we hopefully should be able to know that the first term here, what is the first term? If it just fits our rule that we had before, what's our first term that we're dealing with? 4, right? Okay, this matches that. Now, whenever we get over to the second one, doesn't work that way. We're actually going to have to plug in a value. That's okay. It's not really like it's that big of a deal. So we have our first term. What is our common ratio? What number keeps getting multiplied by itself? What number is the base of my exponent? 3. Now, do we have all the information that we need? You bet. We have the first term, we have what r is, and we know how many terms. How many terms are we going to add up? 10. Okay? Right there at the top. Whatever number that is, that tells us how many numbers we're going to add together. So then whenever we plug everything in, if I'm going to have s sub 10, I'm going to take it and I will have the first term, so 4 times 1 minus 3 to the 10th power divided by 1 minus 3. Now, what I would suggest to you, okay, whenever you do this, okay, the one thing I want as far as out of you is I want to see this, as far as whenever we test over it, quiz over it, whatever you want to call it, I want to see this. After you get this part, though, I'm okay with you going to the calculator and going from there. Now, I'm going to show everything, and I'm going to show all the values, but that's not necessarily what you have to do. If you don't want to, I'm going to tell you the order in which I would plug everything in. Okay? And again, I would leave everything in the calculator. I wouldn't let it leave. Like, I would just take your answer and just keep it in there and just keep going from there. Okay? So if you want to know the order, I would put like a little 1. I'm just going to highlight certain ones. Okay? What you want to do first is work kind of inside out. So if I work inside out, I'm going to do 1 minus 3 to the 10th power first. Now, if you do 1 minus 3 to the 10th power, what you're going to end up with is you're going to end up with negative 59,048. Then from there, what I would do is I would divide that number by negative 2. Again, I'm going to write everything out. Okay, so what you get and what I get is going to be a little bit different. And then I would multiply everything by 4. So if I have the 4 out here, then I'm going to do everything. So I'm going to do what's in green first. I'm going to type in 1 minus 3 to the 10th power. I'm going to hit enter. I'm going to get, in my calculator, negative 59,048. Now, in my head, I should be able to do 1 minus 3, and I'm going to divide it by negative 2. Okay, whenever I do that, okay, then I'm just going to multiply by 4. Or even if you wanted to, you could simplify 4 and negative 2 and multiply the negative 59,048 by negative 2. So whenever I multiply by 4 and go from there, the sum of the first 10 terms that I have is 118,096. The only thing that's different between the first one and the second one is that this rule, formula, whatever you want to call it, here, does not fit the rule that we gained yesterday. Okay? It doesn't have the n minus 1 power, so it's its own rule. All right? That's okay. So the only thing that I'm going to have to do here is I'm going to have to figure out what my first term is. And you can always do this by just taking 1 and plugging it in. So having 1/2 times 5 to the first power. So what's 1/2 times 5? 2.5. I would just leave it as 5/2, but if you want to put it as 2.5, that's okay. What is my common ratio? What's my common ratio here? What number keeps getting multiplied? What number is the base of my exponent? 5. Again, now it just becomes plugging everything in. S to the 6th power, or S sub 6, excuse me, not S to the 6th power. S sub 6 equals, I'm just going to write it as 5/2 times 1 minus 5 to the 6th power divided by 1 minus 5. Again, I want to see this. From there, I'm okay with you having just the answer. Okay? So 1 minus 5 to the 6th power is negative 15,624. Then I will divide by a negative 4. Then I will take that and multiply it by 5 halves, or 2.5, and get a total of my first 6 terms as 9,765.